Now here the question is this integral from pi by 2 minus alpha to pi by 2 sin theta cos inverse cos alpha cosec theta d theta. It is pi by 2 1 minus, and here since the variable of integration is theta, it should be parameter which is alpha. So it should be pi by 2 into 1 minus cos alpha. Now here we have alpha in the limits. We also have alpha as a parameter in the function. So here we have to use Leibniz integral formula in the general form. So we write f alpha and LB equal to pi by 2 minus alpha to pi by 2, and then sin theta cos inverse cos alpha cosec theta d theta. We'll differentiate this function with respect to alpha. Now this first part is, we write this integral from pi by 2 minus alpha to pi by 2, and here we'll partially differentiate this function with respect to alpha. So it'll be sin theta and then minus 1 upon under root of 1 minus cos square alpha into cosec square theta into, now cosec theta as it is, and derivative of cos alpha will be minus sin alpha into d theta. Now sin theta into cosec theta, it is 1, and then plus, I will put upper limit. So here it will be sin pi by 2 cos inverse cos alpha into cosec pi by 2 into derivative of upper limit, and derivative of upper limit is 0 since this upper limit is constant, and then minus sin pi by 2 minus alpha cos inverse cos alpha and cosec pi by 2 minus alpha into derivative of lower limit, and derivative of lower limit will be simply minus 1. So now we can write this f dash alpha as this integral from pi by 2 minus alpha to pi by 2 sin alpha d theta upon under root of 1 minus cos square alpha into cosec square theta, and then this one is 0, and here will be sin pi by 2 minus alpha is cos alpha, minus and minus is plus, so it will be plus cos alpha, and then cos alpha into secant alpha, it is 1, and cos inverse 1 is 0. So this is also 0. So from here we can write f dash alpha is this integral from pi by 2 minus alpha to pi by 2 sin alpha d theta, and we'll change this cosec square theta as 1 upon sin square theta. So it will be under root of sin square theta minus cos square alpha, and in the numerator we'll have sin theta. Now we change sin square theta as 1 minus cos square theta, and cos square alpha is 1 minus sin square alpha. So we can change this integral as f dash alpha equals this integral from pi by 2 minus alpha to pi by 2. We'll take sin alpha and then sin theta d theta, and here it will be under root of sin square alpha minus cos square theta. Now what we'll do is we'll let cos theta as t. Now we take cos theta as t, minus sin theta d theta will be dt. So we can write f dash alpha is sin alpha into minus dt upon under root of sin square alpha minus t square, and then lower limit, if we put theta is pi by 2 minus alpha, it will be simply sin alpha, and then cos 90 is 0. So we'll get these limits, and then we can write f dash alpha is this integral from 0 to sin alpha dt upon under root of sin square alpha minus t square. Now here sin alpha is constant and 1 upon under root a square minus x square is sin inverse x upon a. So it will be sin inverse t upon sin alpha from 0 to sin alpha. So we'll write f dash alpha is sin alpha, and here it will be sin inverse 1 minus sin inverse 0, and sin inverse 1 is pi by 2. So we'll write f dash alpha is pi by 2 sin alpha. Now we'll integrate this function with respect to alpha. We'll get f alpha and it'll be pi by 2 into minus cos alpha plus c. Now we'll also need to find initial condition, and the initial condition is when alpha is 0, we have both the limits same. In that case, value of f alpha will also be 0. So we'll put the value of alpha as 0, then f alpha is 0, and it'll be minus pi by 2, and cos 0 is 1 plus c. So value of c is simply pi by 2. That means value of this integral, which is f alpha, will be pi by 2 into 1 minus cos alpha, and this is what we need to prove. Pi by 2 into 1 minus cos alpha.